Okay, let's take a look at number 4 on the 4A handout. This is a little different from the other problems that we've been doing. We've been doing square root problems. This one's just graphing a couple of lines. Um, and it gets at a new concept because these lines are related to each other, and we'll talk about how in a minute. So the first one here, graph this line. I'll do that one in like this pinkish color here. So f of x equals 2x plus 6. You might remember it's like in this form, mx plus b form. If we plugged in 0 right here for x, you would get 6 for the y-intercept. So we have the point 0.06 on this line. And then the slope is 2. So it's like 2 over 1. That's rise over run. So up 2 over 1. Up 2 over 1. So we get that. Let me get, excuse me. Let me get my ruler out and I'll draw that line. Kind of looks like this. Is that pretty good? Yeah, I think that's okay. So there's the line. F of x equals 2x plus 6. Okay. And then I've got this line over here, g of x equals 1/2 x minus 3. So I'll do that one in green. So if x is 0, y is negative 3. So I'm going to come down here, 0, negative 3. And then what? Slope is 1/2. So up 1 over 2, up 1 over 2, up 1 over 2. And if I draw this one out, let's see here. Hold on. Let me get that. It's kind of glitching on me here. Ah, there, sort of like that. Oh my gosh. There. Okay. And now my graph's not going to be perfect, but it's okay. And let's graph the line y equals x also. So let's do that one in this color. Y equals x is just slope of 1 right through the origin. And it says use a dash line for that one. Okay, so there's y equals x. The green one was y equals 1/2 x minus 3. Okay. All right. So there's everything. Now it says pick any 3 points on f of x. And where do they intersect? Sorry, A says where do they intersect? And it looks like they intersect around here. All 3 of them actually look like they intersect around there. Now I'm not actually sure what coordinate that is. I think, does it end up being like -6, -6? I think it does. So in fact, we can prove it. When they intersect, we're solving this system. 2x plus 6 and y equals 1/2 x minus 3. And so to solve a system, we can use substitution. So 2x plus 6 is going to equal 1/2 x minus 3. To get rid of the fraction right away, we can double both sides. So I'll just multiply by 2. And so then we get 4x plus 12 equals 1x minus 6. And then let's see, this will be 3x equals negative 18 if you subtract the 12. And then divide 3, and you get x equals negative 6. And then if you plug it back in, like into either of them, you get y equals negative 6 also. So negative 6 is where they intersect. Okay. All right. Now it says find the coordinates of any 3 points on F. Okay, so F I have a few of them labeled here. Here's 0, 6. Whoops. Here's 0, 6. This one was up 2 over 1, so this is at 1, 8. And this one right here is at 2, 10. Okay, so on F, I've got 0, 6, I've got 1, 8, and I've got 2, 10. Okay, so what I want to show is that on the graph of G, these points show up, but they're flipped. So when x is 6, here, let me actually write it this way. This might be easier. X, y equals 2x plus 6. So we know 0, 6, 1, 8, and 2, 10. Okay, and you can get these y values just by plugging in the 0, 1, and 2. Okay, so on G, we want to show that the flipped coordinates are on there. So that means instead of x being 0 and y equaling 6, I want to show that when x is 6, y is 0. And if you actually look at it, that was one of these points that we plotted right here, 6, 0. And to prove it, you can say, okay, when x is 6, y equals 1/2 6 minus 3. That's 3 minus 3, which is 0, right? So 6, 0. If we plug in 8, then I got y equals 1/2 8 minus 3, which is 4 minus 3, which is 1. So look, they're flipped. And then same thing if I do y equals half of 10 minus 3, then I got 5 minus 3 is 2. So 10, 2. Okay, so that's this point right here at 8, 1. And another one here at 10, 2. Okay. How are the graphs of f and g related with respect to this blue line right here, y equals x? Well, if you look at it, this point right here is reflected over to that point. This point right here gets reflected over to that point. This point right here gets reflected over to that point. So this pink line or red line is reflected across the blue line and you get the green line. It's kind of like the blue line's a mirror, essentially. Or if you folded the page along the blue line, those two, the red and the green one, would match up. So how are they related? They are F and G are reflections of one another across the line y equals x. And so if you switch the coordinates, if you take something like this and you flip it over to something like that, or 210 turns into 10-2, that's the same thing as saying reflect across the line y equals x. Okay? It's, yeah. Okay. All right. And I'll tell you one other thing about these right now. These things, these two functions, when they're reflections of each other across that line, they're called inverses. So when two functions, let's say, functions or graphs are reflections of one another across y equals x. They're called inverses of one another. So in this case, you could say f is the inverse of g, and g is the inverse of f.